Hi, welcome to today's math lesson. Our TEK is 8.7a, and we're going to be finding the volume of cones. Our do now reads in each diagram, line K is parallel to line L, and line T intersects lines K and L. So on all four of the angle measurements or lines, we can see that K is on top, L is on bottom, and line T is the transversal. So we see that this upper left-hand angle is 113, and this lower right-hand angle is 113. This upper right-hand angle is 127. This lower left-hand angle is 127. So then we're given that this upper right-hand angle is 79, and we have to figure out this lower right-hand angle. And following the same rule or pattern that we see, we can see that this lower left-hand angle would be 79 degrees. And another way to confirm that is if this is 79 degrees, its vertical angle or its opposite angle would also be 79. And angles that are in the same position, as you can see, because this would be 79. And this is the lower left-hand angle of this top line. And this is the lower left-hand angle of this bottom line. This is 79. And of course, vertical angles are congruent or equivalent, have the same measurement. Our TEK for today, again, is 8.7a. Our lesson target is that scholars will solve problems involving the volume of cones. And our DOL is that given 4 problems, scholars will solve problems involving the volume of cones with 100% accuracy. Some vocabulary words for us to review are the words diameter. And the diameter is the length from one side of the circle to the other side of the circle. So the diameter is twice as long as the radius because the radius is half since it's going from the middle of the circle to the end of the circle. So another way to think about the radius is that it's half the diameter. Since this is not a 2D shape, it's a 3D shape, there's a height. And in this case, it's this purple line right here. And the base shapes of cones are going to be circles. And so the base area, which is what this uppercase B represents, is going to be the area of a circle. And the area of a circle is pi radius square. So to break down this formula for volume of a cone, we have 1/3 or 1/3 times the base area, which is the same thing as pi radius square, times the height. And so that's why we can simplify or further extend the equation to be V is equal to 1/3 times pi r squared times height. This first iDo problem reads, find the volume of the cone, and we have to round our answer to the nearest tenth, and we have to use 3.14 for pi. So our volume for a cone is going to be V is equal to 1/3 times uppercase B or big B times H. And this B represents the area of base. And in the case of a cone, the base shape is the shape that if you were to lay this 3D object on a surface like a table, the shape that's touching the table. So that shape is going to be the circle right here. So we can continue with this formula. We have V is equal to 1/3. Since we know that the base shape is a circle, the area formula for a circle is pi radius square times the height. And then next we're going to plug in the numbers. So we have V is equal to 1/3. Pi, we're using 3.14. In this case, in this diagram, we're given the diameter, not the radius. So if our diameter is 6 feet, then our radius has to be half of that. Half of 6, or 6 divided by 2, is 3. So we have 3 feet. Or 3 squared. And lastly, we're multiplying that by our height, which is 7. So the one key thing to remember is that when we multiply, we're not multiplying 1/3 times 3.14 times 3 times 7. We're multiplying 1/3 times 3.14 times 3 times 3 times 7 because our radius is square. So when we do that, our answer is about 65 0.9, since we're rounding to the nearest 10th place. And our unit for this problem is feet. And since it's volume, it's going to be feet cubed because it's a 3D shape. So feet to the power of 3. So our answer to this I-do problem is 65.9 feet cubed. This next I-do problem reads, orange traffic cones come in a variety of sizes. So this is an example or a picture of a traffic cone. We have to approximate, which is another word for estimate, the volume in cubic inches of a traffic cone that has a height of 2 feet and a diameter of 10 inches. And again, we're using 3.14 for pi. So we're going to start off writing our volume equation, which in this case is V is equal to 1/3 times big B or uppercase B times H. So again, the B represents the area of the base shape. In this case, since we're working with cones, our base shape is a circle. So the area formula for a circle is going to be 1/3 times pi radius square times height. And before we can plug in any numbers, we are looking in the problem and it says that they want the volume in cubic inches. So the diameter was given in inches, but the height was given in feet. So we have to convert this 2 feet to be in inches. So we have our height is 2 feet. And so if I think about it, I know that there's 12 inches in a foot because when you have a ruler, there's 12 inches and that's considered a foot. And so if we have 2 feet or 2 of those rulers, 2 times 12 or 12 plus 12 is 24. So our height is going to be 24 inches. And then another thing to note is that in this problem, they gave us what our diameter is, right? Our diameter is 10 inches. But our equation needs us to find out what our radius is. So our radius is half of our diameter, so half of 10 is 5. So now if we plug in the numbers, we have V is equal to 1/3. We're using 3.14 as pi. Our radius is going to be 5. And then our height is going to be 24. So remember that when we're multiplying this, we are not multiplying 1/3 times 3.14 times 5 times 24. We have to multiply the 5 twice, since it's radius square is what the equation is. So when we do that, we get about 628. Our unit for this problem is going to be inches, since that's what they asked us to find it in. And since it's volume, it's going to be inches to the power of 3, which is also called inches cubed. There's a couple of you-do problems. And lastly, we're going to end with your 4-problem Google Form DOL. Thank you so much for following along in today's math lesson, and see you in tomorrow's math lesson, in tomorrow's math video.